Hello, math humans. We are going to do section 1.1a today. We're going to be talking about rectangular coordinates. We are going to review the rectangular or the Cartesian coordinate system. We're going to talk about the distance formula, the midpoint formula, and then the Pythagorean theorem. So as we go along, you are not required to write down the objectives. Those are just there so you know what we're going to talk about in the video. But then everything after this you are responsible to write down. If I go too fast, you can pause me and then rewind me if you need to. All right, all of this information you've seen before, but we're going to go back and try to get our brains turned back on. So the first thing that we're going to talk about is the Cartesian coordinate system. And if you'll remember, it's just here is the x-axis and here is the y-axis. Later this semester, we are going to talk about several different types of coordinate systems, and so this will be the first one that we go back and talk about. We talk about the quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Remember that ordered pairs give the location of a point in the coordinate system, and then that has coordinates x, y. We always do x first and then y. The values in each of the quadrants have specific signs. X is positive and y is positive in the first quadrant. In the second quadrant, x is negative and y is positive. In the third quadrant, they are both negative. And then in the fourth quadrant, x is positive. Those are just information pieces that we want to remember because we will need to discuss that later as we go. Your book likes to do what I call the shotgun approach, and so they like to give you lots of new information pretty quickly with not a lot of other information that goes along with it. So the first couple of sections would be what I call just a shotgun approach. Our next topic is the Pythagorean Theorem. Sorry, I just got done with a bike ride, and my friend had a flat, and I'm really hoarse. All right, the thing that you need to remember about the Pythagorean Theorem is that it must be a right triangle. Okay, so you can't do math with the Pythagorean Theorem unless it is a right triangle. And if you'll remember, so there's our little right triangle. We have a leg, and the hypotenuse. So the Pythagorean theorem says that a squared plus b squared is equal to c squared. And you've been doing this for a long time, so I won't spend much more time on it. There are these cool things, and they're called Pythagorean triples. And we use them just to make our lives a little bit easier with math, because then I don't have to work as hard, so I'll only do one of them to show you. The Pythagorean triples that we want to know would be like a 3, 4, 5. Obviously, the 5 is the hypotenuse because it's the longest side. And if I used these to see if they actually worked in the Pythagorean theorem, I would know that 3 squared plus 4 squared, I want to see if that's true, is equal to 5. So 9 plus 16, forgot the squared, is 25. 25 does indeed equal 25. So the nice thing about having some Pythagorean triples are that you don't have to do this math. You can just memorize a couple of the different Pythagorean triples. And we're only going to look at 3. We have the 3, 4, 5, the 6, 8, 10. Obviously, the 10 again is the hypotenuse, and then the 5, 12, 13. The next equation that we want to go back and remember is the distance formula. We'll see if my pen's going to decide to work. Maybe not. Might have to switch to a different one. All right. The distance formula is used for lines that aren't, and aren't is the key word, vertical or horizontal. Okay? So if I had what I call an oblique line, and I wanted to find the distance between point A and point B, then I would use the distance formula. That really bugs me, sorry. So the distance formula says that the distance is equal to the square root of the distance, or the difference, in the x-coordinates added to the difference in the y-coordinates. So a couple of things about the distance formula. A would have coordinates, we'll call this guy x1, y1, and B would have coordinates x2, y2, okay? These values are what's substituted in here. So the distance formula is actually kind of interesting. I take the difference in the x's and I square it to make sure that the values are positive because distances are positive. And then I do the same thing for the y's. I square it to make sure that the value is positive. The reason that I then have to take the square root is because I have to undo the squaring that I did to ensure that things are positive. When you do this math, you want to make sure, as we are in big kid math now, that you do all of this in one fell swoop in your calculator. Don't do it in little stages and then keep continuing to round, because as you do that, that creates a lot of error. So let's do our first example. If I can finally talk. All right, so in this one, we're going to know that A is going to have coordinates of -2, 1, and B is going to have coordinates of 3, 4, and I want to find the length of AB, okay? And if you'll remember from your geometry notation, that just means you want to find the length of AB. When I use a formula, I always write that formula out. I call it a naked formula without, that's supposed to be a 1, without any values in it, because it's just a way, A, of memorizing the formula, and B, it allows me to not make as many mistakes when I substitute values in. So then my distance is going to equal the square root of, and I'm going to do 3 plus 2, it's this minus a minus, quantity squared, plus 4 minus 1, quantity squared. And then I'm just going to show you how I would do that in my calculator, because I don't want to do this in a lot of little steps. Hopefully you'll be able to see my little grapher. Oh, there we go. All right, it's got some fun math on there that we'll do later. So I'm going to do second square root, and I'm going to do parentheses 3 plus 2 quantity squared, and then added to 4 minus 1, and then quantity squared. Get outside the radical and hit go, and there is my miraculous distance, okay? If I want this in decimal form, my responsibility is to write down the solution to 3 decimal places. We always have to, in PreCalc and any math beyond PreCalc, write our answers to 3 significant decimals, okay? So that means you round to the 3rd decimal place. Alrighty? If I wanted to leave my answer in radical form, then I would have done distance is equal to, 3 plus 2 is somebody loves me, woo, 5 squared plus 4 minus 1 is 3 squared. This is 25 plus 9. So my distance in radical form would have been the square root of 34. Either answer is appropriate. I don't mind which you use unless the problem asks you for an exact. Remember, exact means no calculator. All right, let's move on to our next example. So this is going to be example 2. The examples are numbered in case you have a question about them when you come to class. It makes it easier to ask. So we're going to be given it that the coordinates of A are 2, 1, the coordinates of B are 4, 0, and the coordinates of C are 5 and 7. And I want to show that the points A, B, and C are the vertices, except I spelled it wrong, vertices of a right triangle. My bad. All right. Anytime you're given information like this, I always recommend that you graph first. So I'm just going to sketch a cute little graph. Okay. I'm only going to do the first quadrant because these 3 points are all in the first quadrant. So I'm going to have 2 and 1, and I'm going to label that point A. And then I have 4, 0, so this is B. And then I have 5, 2, 3, 4, 5, 6, 7. That guy up there is C. And then I'm going to connect the dots. All right? It looks like, we can't assume, but it looks like that the right angle is right there. So what I'm going to do is I'm going to manage this information using the distance formula. There's lots of different ways I can show that this is a right triangle, but for right now, I'm going to use the distance formula and the Pythagorean theorem. So the distance formula is x2 minus x1, quantity squared, y2 minus y1, quantity squared, and then I'm going to find the different distances. I'm going to leave them in radical form, and you'll understand why in a moment. So if I do AB, that's going to be 4 minus 2, quantity squared, 0 minus 1, quantity squared. And I'm not going to take the time to do that math. I'm going to simplify it because as the brilliant math humans that you are, I think you can manage that math. And then I'm going to do AC. And when I do the math for AC, I would get 5 minus 2, quantity squared, 7 minus 1, quantity squared, and I'm going to get the square root of 45. This is not a reduced radical, but that's okay. We're going to leave it like that because I'm going to do the Pythagorean theorem. Then BC is going to equal, and then 5 minus 4, quantity squared, plus 7 minus 0, quantity squared, is equal to the square root of 50. Now, the Pythagorean theorem, remember, because we are trying to show that it's a right triangle, shows that the leg squared and a leg squared is equal to the hypotenuse squared. So I'm going to take radical 5 and square it, and I'm going to take radical 45 and square it, and I want to know if that equals the square root of 50 squared. Remember, if you square a radical, I get 5 plus 45. Does that equal 50? Indeed, it does. So we would say then that triangle ABC is a right triangle. And we showed that by using the distance formula and the Pythagorean theorem. All right, my next example, let's see if you can see the green, if it will show up. So for example 3, yay, we like green. So A is going to be 1, 4, and then, oh, my bad, I got it out of order. That's okay, I'll give you this, and then I'll give you the formula off to the side. And B is 8, 4. And I want to find the midpoint of the segment. That's all right, we can backtrack a little bit. So if you want to know how to find a midpoint, that handy-dandy little formula is the average of the x's and the average of the y's. Super simple. You just have to remember when I'm doing the distance formula, I subtract. When I'm doing the midpoint formula, I add. And by the way, you'll need to have those memorized because now that you're in big kid math, I won't ever give you that information. All right, so if we finish our example and I want to find the midpoint of segment AB, then my midpoint is going to equal 1 plus 8 divided by 2, and then it's going to be 4 plus 4 divided by 2. So then this is going to be 9 over 2 and 8 over 2. And we're going to simplify that to be 9 over 2 and 4. Okay, fractions are your friend. We like fractions. There is no reason to take the time to turn this into a decimal. My preference would be that you just leave it alone. There's no reason to convert it. I would report my answer at the end, and I would say that the midpoint is 9, 2, 4. One of the things that's very important that you learn to do in math is what I call identifying your answers. You always want to make a statement at the end of your work. What were you looking for, and what is its value? So when you take tests for me, if you neglect to write down what equals a quantity, then I neglect to give you full points. Sad day. All right, let's go to our next example. So we're going to be on example 4. All right, this one is going to talk about Barnes & Noble. And because our books are older than dirt, the data is older than dirt. But that's okay because we can still do math on our older than dirt data. Had annual sales of I wrote of twice, of 5.1 billion in 2005. See, I told you our information was a little bit old. And then it had sales of 5.4 billion in 2007. And my task is, what were the sales in 2006? All right? So the cool way to do this, and since we talked about a midpoint, it's important to notice I'm given 2005 and I'm given 2007. So then 2006 is smack in the middle, so then I can use the midpoint. I'm going to write down my given information. I'm going to write it as 2005 and then 5.1. And then I'm going to write 2007 and 5.4. Okay, those are my two data points. Those came from the words. And now I'm just going to calculate the midpoint. So the midpoint, and just to illustrate the point, if I did 2005 and added it to 2007 and divided by 2, I would get 2006. That's kind of fun. Okay, and now I'm going to do the 5.1 plus the 5.4 and divide by 2. And when I do that math, I'm going to get 5.18. Okay, now I need to answer the question. So I'm going to say the sales in 2006 were equal to $, because that's the units, 5.18 billion. It's important to make sure that you get the units in there, because without the units in there, the problem just doesn't seem to make a lot of sense. All right, that is it for today. I will see you soon.